Hi guys, we are carbon dioxide captors. I'm Wei, I'm Jinru.
I'm Brian.
I'm Daniel.
And I'm Bubur.
We are from College Tingkatan 6 Prauniversiti, Desa, Malaysia. Today we are going to present the carbon dioxide direct air capture. The aim of this project is to capture carbon dioxide in the atmosphere and to reduce the impact of greenhouse effect to achieve Sustainable Development Goal 13, climate action. Now, let's delve into it. The current global ecological crisis is caused by climate change. Since the pre-industrial era, climate change has resulted in an increase in average global temperature of around 1.1 degrees Celsius, resulting in more frequent natural disasters. SDG is a set of 17 goals that the United Nations set in 2015. The goals are intended to create a more sustainable world in 2030. Here are the targets of SDG 13, climate action. SDG 13 plans to increase resilience towards climate-related hazards and natural disasters. SDG 13 aims to integrate climate change measures into national policies. SDG 13 focuses on improving education and awareness of the people about climate change. Lastly, SDG 13 intends to promote mechanisms to help least developed countries and small islands developing. We plan to manage climate change by reducing greenhouse gas emission, using renewable gas, and by developing clean technology.
Now, I will be talking about the disadvantages of high levels of carbon dioxide in the atmosphere. First, an increasing level of carbon dioxide in the atmosphere can cause a greenhouse effect. Greenhouse gases such as carbon dioxide will trap the heat of the sun from escaping to the outer space. This will cause the temperature of Earth to increase slowly, which will lead to climate changes and global warming. According to current data, the average global temperature has increased 0.2 degrees Celsius per decade. Next, a high level of carbon dioxide in the atmosphere can cause harms to plants and crops. Although a high concentration of carbon dioxide can boost the rate of photosynthesis of plants, an extremely high concentration of carbon dioxide will inhibit photosynthesis of plants. Hence, crops yield will be reduced and causing food shortage. Last but not least, a high level of carbon dioxide in the atmosphere will cause ocean acidification. When the carbon dioxide in the air reacts with ocean water, it will produce carbonic acid. Decreasing in pH of ocean water hinders the growth of marine animals by affecting their sensory abilities to find food and avoid predators. This causes the food chain disruptions and destroy the ecosystem.
So now I'll talk about our model. Our 3D model is made by using Blender animation. For the first part, the air contact system. A fan is attached to the container to suck in air from the atmosphere. At the bottom of the container, there is a mixing system that uses pitch blade turbines to increase the rate of reaction. When carbon dioxide in the air comes in contact with potassium hydroxide, it reacts to form potassium carbonate and water. After that, a centrifugal pump is used to pump the mixture into the distillation unit. The potassium carbonate and water is heated by using a heating element that is set at 100 degrees Celsius. The water vapor will then be cooled and converted to liquid water at the condensing coil and then accumulate at the storage tank for purified water. After that, the concentrated potassium carbonate is then pumped into the pellet reactor by using another centrifugal pump. In the pellet reactor, we use calcium hydroxide to react with potassium carbonate to form calcium carbonate and regenerate potassium hydroxide. The mixture is then separated using a hydrocyclone. A hydrocyclone is a centrifugal device used to separate solid from the bulk fluid. The mixture is fed into the hydrocyclone tangentially at a certain pressure. This creates a centrifugal movement, pushing the heavier face outwards and downwards alongside the wall of the conical part. As the diameter of the conical part decreases, it increases the speed and so enhances the separation. Finally, the concentrated solid, which are calcium carbonate, is then discharged through the apex and transferred into the calciner, while the vortex finder in the overflow part creates a fast rotating upward spiral movement of fluid in the center of the conically shaped housing. The fluid, which is potassium hydroxide, is discharged through the overflow outlet, linking to the air contactor system where potassium hydroxide is being reused. In the calcitor, the calcium carbonate is transferred. We suggest using concentrated solar power CSP system to heat the calcium carbonate up to 700 to 900 degrees Celsius for decomposition. This forms calcium oxide and carbon dioxide. A compressor is used to compress and store concentrated carbon dioxide in a tank for further uses, whereas the calcium oxide is used to regenerate calcium hydroxide by adding distilled water from the air contactor system. The calcium hydroxide will then be sent to the pellet reactor for further reaction.
Is a recommendation to improve the dry air capture by exploring amine-based solvents such as BPI and TPA-based solvents, which require less heat energy to liberate the captured carbon dioxide, can reduce the cost of the process.
One of the key applications of captured carbon dioxide is methanol production, where captured carbon dioxide is combined with hydrogen to produce methanol, which is a crucial component in fuels and chemicals industry. Besides, captured carbon is combined with ammonia to produce fertilizer that support agriculture. Another key application of captured carbon dioxide is to create synthetic fuels. These synthetic diesels can be used as a direct replacement for traditional petroleum-based diesel, offering a cleaner alternative with reduced carbon emission. Captured carbon dioxide can be used in building materials too. One of its examples is concrete strengthening by using carbon pure technology. This process offers a benefit in which it can increase the strength of the concrete, making it more durable. And because of this strength improvement, we can reduce the carbon dioxide emission during cement production. As we know, cement production is a major contributor to global emissions. Lastly, we will focus on the usage of captured carbon dioxide in food and beverage industry. The first application is in freezing and chilling, specifically through dry ice. It helps to maintain food freshness during storage and distribution. The second application is pH control in food production. By using carbon dioxide, manufacturers can adjust and stabilize the acidity, which help to improve product shelf life, texture, and overall taste.
In short, by aligning carbon dioxide utilization with local industrial needs, policy framework, and technological readiness, the regeneration capture cycle will transition from a cost center to a value-generating process, supporting both the economic and global goals, which is to prioritize applications with permanent sequestrations such as mineralization or circular carbon use, for example, renewable fuels, rather than allowing it to accumulate in the atmosphere, thus reducing the effect of global warming.
Aside from that, we can achieve net zero emission target by reducing the reliance on fossil fuel and decreasing the carbon intensity, which supports the global climate goals. That's all from us, carbon dioxide catchers. Thank you for listening.